Okay, everybody, here we are in section 5. The last section is chapter 3 for us. There's the title, Systems of Equations in 3 Variables. And in this section, you're actually going to build upon what you learned with 2 variables with 2 equations. We have 3 variables now with 3 equations. So rather than call our answer an ordered pair, we're going to call it an ordered triple. So you see the red definition, a solution of a 3-variable system in the form of x, y, z, not just x, y anymore. So we have 3 things to solve for. It's going to take a little bit more time, and there will be a calculator version of this. But by hand, it's some things that you've already learned. You just got to be a little bit more careful on following the details. So I want you to think about an hourglass, and here's what I mean. It's a 3-variable system, so we've got to take 2 equations at a time, and we're going to eliminate 1 variable. So that's number 1 right there. Secondly, we need to take the 3rd equation that we've not used yet and combine it with one of the ones we have used and eliminate the same variable. So at number 3, you see, now as a result, we have 2 equations with 2 variables, and we're going to do elimination with them. So if we eliminate at this juncture right here, we end up with 1 variable, and we're able to plug that into the 2-variable equation, which you can choose which one you wanted from up higher in step 3. And once you've plugged in to that one, you'll get a second answer. And finally, you have 2 variables that you can plug into the 3-variable equation, which means you will solve for the 3rd variable. Now, this is just kind of an overall view. So I'll let you kind of look at the overall thing. We're going to do a problem here in a second. Just one problem, because they take a bit of time. But I want you to see how it's done. Alright? So let's turn over here. And we're going to start up here at the top. Use elimination. So here's our question. It says, solve the system of equations right here. 3x minus 2y plus 4z equals 35. Negative 4x plus y minus 5z equals negative 36. And 5x minus 3y plus 3z equals 31. Now I want you to notice this variable right here. Alright, you see the y. It has a coefficient of 1. That's a good indicator of which one you want to start with to try to eliminate. So you notice I've labeled my equations A, B, and C, so you'll know exactly what I'm doing each time. So we go on down here, and I'm going to pick A and B first. And so I picked those 2, I write them down again, and I notice that my y is the one I want to get rid of. So the second equation, B, if I multiply it by 2, I can eliminate the y's. So I do that, and I show that in red, and you obviously might just have pen or pencil, so you'll just show that, and we'll see it. So down below here, I have written right there the new form. So I have AB on the top, and then I change it to just A, 3x minus 2y, because that one didn't change anything. But the second one is now 2 times b. Alright, notice that change. So negative 8, a positive 2y, a negative 10z, and negative 36 times 2 is negative 72. Now in blue, I have just combined my 2 equations. So that was the elimination process. So notice I get a negative 5x minus 6z equals negative 37. There are no more y's in that blue equation. So that blue equation I hold on to. I'm going to come back to it. Alright, that's why I put it in blue. Alright, so I stop, and I have to go pick another set of equations. So I go back up here to the top, and I used A and B earlier. So I'm still going to use B, but I'm going to combine it with C now. So let's go down here. There's what we just did. And here is where we're going. So you notice on the left I say B and C, but I decide that I need to multiply the y by 3 now, and so I do that. And so you see I have 3b on the next set. So here, let me get right here. Here's my first setup. I realize I got to multiply that by 3, and there it is multiplied by 3, all of those. Alright, so negative 12, positive 3, negative 15, and negative 108. I'm pretty sure those are right. So I combine my equations. I got negative 7x, no y's, they're gone, and negative 12z, and negative 77. I have strategically picked, on purpose, to get rid of my y variables on the first two elimination steps. Notice that, okay? So you see both blue equations in the picture, and I'll scan out a bit. That's on purpose, all right? We want to get rid of our y's in both equations. Now, in different problems, it may be the x's or it may be the z's. In this case, it was the y, because when I look back at my original problem, I noticed that right there in the middle of your picture, the y has a 1, so it might be an easier one to solve for. But once again, you can solve for any, or eliminate any of the ones you like. Okay? So I have my two blue equations. I've got some notes over here on the side. I eliminate the y value for both the equations A and B, and I also eliminated the y value again for B and C. Alright, so next, the two blue equations that we just generated are right here at the top. It says eliminate the two variable equations now. So I have my x and z equations, no more y's. So here we go. I'm going to eliminate the z for this problem. So if you look at my top two equations, I notice that my 6z can go into my 12z, but I need to multiply a negative 2 so that I'll get a different sign. So you notice right here that I get a positive to combine with that negative. So this is the result of right above there, negative 2 times negative 5. This is negative 2 times negative 6. And this is negative 37 times negative 2. I combine these two right here, and I get 3x equals negative 3. Notice I can solve for x now. There's my first answer. I'm on my way. I have two more variables to get, and it starts getting a little faster here. So I solved. Next, I plug x equals negative 1 into a two variable equation. Well, my two variable equations were right up here at the very top. So I selected the first one right here. Okay? So you go on down, and there it is, the first one, negative 5x minus 6z equals negative 37. So I plug in my negative 1 that I just got for x. I solve it for z. So very quickly I've got two answers. I'm missing my y value now, so I'm going to go back and plug in to a three variable system. So in the very bottom you see, now plug the x and the z that you found into a three variable system. Okay? Pause this anytime you need so that you can catch up, or you need to maybe write some things down. So going back to my three variable systems, well, here's the original problem. Those are my three variable equations. I can pick any one of those, okay? A, B, or C. So let me go over here to my last slide. So I said, since we know that x equals negative 1 and z equals 7, we can use them to solve for y. So let's pick equation B from the originals. The reason I picked equation B was, again, because the y value is all by itself, kind of just a 1 coefficient. So I solved for it, and I plugged in, you can see in red, the x value of negative 1 and the z value of 7. Alright, I went through that solving process. 4 and negative 35 is negative 31, and I added 31 over here, and I got negative 5. So in blue, I have my final solution in ordered triple form. My x is negative 1, my y is negative 5, my z is 7, and at the very end, you should always go back in and check your work, or check your answers into your original equations. You could do that on your calculator very easily, and we'll talk about how to do that as well. But anyways, this is the method on how to solve a system of three variables, or three equations, using an elimination method. You could definitely use substitution, but it's a lot messier, and this is kind of the typical format that you will use. Okay? Obviously by hand it takes a lot of work, so you got to be careful. And there's also a method on the calculator, but we're going to be able to do both. So take some notes on this, be ready to talk about this in class, and if you have any questions, bring those to me. I'll try to provide some answers for you. So anyways, Once again, always flip and don't flop.